Welcome back with the next chapter for carbon and its compound. Carbon. Carbon is a non-metal with atomic number 6 and it is represented by a symbol C. The name carbon is derived from the Latin word carbon which means coal. This is because it is the main constituent of coal. The amount of carbon present in the earth crust and the atmosphere is very small. In fact, all the living things, plants and animals are made up of carbon compounds. The earth crust has only 0.02% carbon in the form of minerals like carbonates, hydrogen carbonates, coal and petroleum, and the atmosphere has 0.03% of carbon dioxide. A large number of things which we use in our daily life are made up of carbon compounds. Our food materials like grain, pulses, sugar, tea, coffee, fruits, and vegetables, etc., are carbon compounds. The materials like cotton, silk, wool, nylon, which are used for making clothes, are carbon compounds. The fuels like wood, coal, kerosene, CNG, LPG, natural gas, which are used for cooking food and running vehicles, are carbon compounds. Versatile nature of carbon. Carbon is known to form more than 5 million compounds. The existence of such large number of compounds is due to that some unique property of carbon, which are as catenation. Like that catenation, some more be there. First we discuss about that catenation. Carbon atom possess a unique property to link together to form very long chain, and this property is referred to as that catenation and may be defined as the property of atoms of an element to link with one another by a stable covalent bond to form straight chains, branch chain or ring is called as catenation. The property of catenation is shown by other elements also but to a very small extent. Carbon exhibits this property to maximum extent due to that following reason. First is that carbon cannot donate or gain 4 electrons required to gain inert gas configuration and therefore shows the tendency to form covalent bonds. Due to its small size, shared electron pairs are strongly held by both nuclei which result in the formation of strong covalent bonds. In practice, it has been found that covalent bonds formed by carbon are exceptionally stable. A large number of carbon atoms can join together to form a straight chain, branch chain, and a ring. Due to higher carbon-carbon bond energy, that is 348 kilojoule per molecule, the long chain formed by that carbon are stable and the tetravalency of the carbon also help in catenation. Carbon possesses 4 electrons in its valence shell and this can form a stable covalent bond by sharing them with other carbon atom. Then the capability of forming multiple bonds. Due to small size and the presence of 4 valence electrons, a carbon atoms can form multiple bonds with some other carbon atoms as well as with other atoms like oxygen, nitrogen, etc. This increases the variety of carbon formed by it and hence the number of that compound is tremendously increasing. Some physical properties of carbon. We know that the atomic number of carbon is 6 and the atomic mass is equal to 12.0107 AMU. Melting point 3823 Kelvin and boiling point is 4098 Kelvin. The density will be 22,670 gram per centimeter cube and the phase, that is in room temperature, it will be solid. Then organic chemistry. The compounds having organic origin, that is compound found in living organism, are known as organic compounds. The branch of chemistry dealing with the study of compounds having organic origin, that is compounds found in living organism, is called organic chemistry. In modern days, organic compounds are not restricted to living system. Various organic compounds are known which came from non-living system. For this reason, modern scientific defines organic compounds as that compounds made up of only carbon and hydrogen, that is hydrocarbon and their derivatives. This redefined organic chemistry as the branch of chemistry dealing with the study of hydrocarbons and the compounds which could be thought of as their derivatives of hydrocarbons. Bonding in carbon, that is covalent bond. As neutral atoms, carbon has an electronic configuration 2 and 4. To gain inert gas configuration, carbon can either donate 4 valence electrons or gain 4 electrons. But it cannot do so for the following reason. That is, carbon is a small atom and its valence electrons are strongly attracted by its nucleus. Therefore, it cannot lose 4 electrons as it requires large amount of energy. Second is that carbon cannot gain 4 electrons because addition of 4 electrons in valence shell will result in strong electronic repulsion between 8 electrons now present in valence shell, and then the energy required to overcome this repulsion is very high. To acquire inert gas configuration, carbon can only share their 4 valence electrons with that other atoms forming a covalent bond. A covalent bond can be defined as a chemical bond formed between two atoms by mutual sharing of valence electrons so that each atom acquires the stable electronic configuration of the nearest noble gas is called as covalent bond, and the number of electrons contributed by each atom for sharing is known as that covalency, and the compounds formed by sharing of electrons are called covalent compounds. The concept of covalent bonds are given by Langmuir and Lewis to explain the bonding in non-ionic compounds. There are mainly three types of covalent bond, that is single covalent bond, double covalent bond and the triple covalent bond. Single covalent bond, that means mutual sharing of one pair of electron, while in double covalent bond mutual sharing of two pairs of electron, and the last triple covalent bond, which is the mutual sharing of three pairs of electrons. That means the covalent bonds which will be discussed, that is of three types. If each atom contributed one electron, the covalent formed by is called a single covalent bond and is represented by a single line. And if each atom contribute two electrons, the covalent bond formed is called as double bond and is represented by a double line. And that last, if the atoms contribute 3 electrons, the covalent bond formed is called a triple bond and is represented by a triple line. Formation of a single covalent bond in hydrogen molecules. The atomic number of hydrogen is 1, its electronic arrangement is 1, it has one valence electron, it needs one electron more to attain stability. So, two hydrogen atoms share one pair of electrons, resulting in the formation of a single covalent bond in hydrogen molecules H2. That means in hydrogen molecules, both hydrogen atoms share their electron, that is single electrons, to form a single covalent bond. As shared pair is shared by both atoms, they acquire inert gas configuration of helium atoms in valence shell. Shared pair is under influence of both nuclei and therefore electron participating in covalent bonding are not available as free electrons. For this reason, the properties of the covalent compounds are different from ionic compounds. Formation of double covalent bond in oxygen molecules. The atomic number of oxygen is 8, its electronic configuration is 2, 6. It has 6 valence electrons. It needs 2 electrons more to attain stability. So, 2 oxygen atoms share 2 pairs of electrons, resulting in the formation of double covalent bond in oxygen molecules O2. That means in oxygen molecules, both oxygen atoms contribute 2 electrons, thus share 2 electron pair to form 2 covalent bonds. As shared pairs are shared by both oxygen atoms, they acquire inert gas configuration of neon atoms in valence shell. Such bonds are called double bond. Formation of triple covalent bond in nitrogen molecules. The atomic number of nitrogen is 7. Its electronic configuration is 2, 5. It has 5 valence electrons. It needs 3 electrons more to attain stability. So, two nitrogen atoms share 3 pairs of electrons, resulting in the formation of a triple covalent bond in nitrogen molecules N2. That means in nitrogen molecules, both nitrogen atoms contribute 3 electrons and thus share 3 electron pairs to form 3 covalent bonds. As shared pairs are shared by both nitrogen atoms, they occur in a gas configuration of neon atoms in valence shell. Such bonds are called as triple bond.